So, like even Chiranjeev hit very hard on word-to-vec and things that work, but there's no guarantee. But unfortunately, a class of algorithms usually follow this sort of a model where we don't have guarantee, but it works in real life. At least it makes direct impact on what we see. Okay. So we had seen a lot of keywords like this coming into our literature, day-to-day conversations, reading materials, projects, activities in last maybe a decade or so, and possibly these are the hot topics for everything to do. But is it really the big data that we see? In my mind, there is far more than this that is hidden, or we haven't not even seen possibly the tip of the iceberg. So if you really want to look at the world around us, they are completely disconnected from this data unless somebody really encodes it, types it, captures it, put into a database that we know how to process, how to query, how to retrieve, and how to process. So the challenge now is how this can be enabled at this moment. And that is where the computer vision comes, which primarily looks at the area of, so the sensors or and my experience is extremely limited to the sensor of camera, or at least not even sensor, basically the images and videos when it come out, what to do. Okay, so let us look at why this is important. If you look at the type of apps that we all use, I believe almost all of them will ask you, like, can I use your location and GPS? Or at least most of the apps that we use are now, so we know that, okay, GPS has revolutionized the way the softwares run on our mobile. And it is, in a way, one of the simplest thing that we can think of, which just gives you the location from a set of, processing a set of signals. What about things like this now? Vision. So what is going to happen is we possibly had camera for long. We don't use it. We use it only for entertainment in the sense of just take pictures in the applications that we are going to see in the next maybe many years. And not just camera. So if you look at the storyline is something like this, that the way the artificial intelligence is being seen by a community, like say for me, what is computer vision's goal? Oh, if you can, or what is AI? I'll say, oh yes, if I can understand an image, it is an AI. Like we have solved a problem. Take a picture and say, who is this? Oh, we have solved the problem. Like we had a set of end definitions of what is computer vision meant to be, or what is artificial intelligence meant to be. Possibly now we are seeing all those had happened already. So that is what now really bothers many of us in the last maybe 3 years, this change. So if you look at what this enables now is this world is now getting connected to the digital world. The physical world is getting connected to the digital world with the help of a set of algorithms that can process and quote unquote understand the data, the world, and possibly provide a representation that is in a way understandable for a set class of applications. So in this space, if you look at what is happening with images and videos, there has been huge change in the last exactly 3 years. Like till 2012, the computer vision people strongly believed that nothing is going to happen. We are going to go at the same pace like this. In 2012, the shock that came to our area was, now we quote unquote call it as an AlexNet. Alex is the name of a student. He was a student at that time. So he came with a deep learning algorithm that suddenly changed the way the object recognition had was performing earlier. Earlier we were in a year. So this area was moving with grand challenges, like we have our own mini Olympiads, where every year many groups participate, and slowly every year like a performance go up by 1%, half percentage sort of thing. And suddenly this graph went like this. You can see that last graph, that red part that you see at the graph, that is where it is really steeply increasing. A large class of problems that we thought will never get solved in our life and we could make our living on it for until our retirement got solved in 2 years' time. So face recognition and many other things that whatever you could think of, the common benchmarks were all beaten up. Now, not in this way, the object recognition, we wanted to move to the next level of understanding. We want to call it as connect to the language, because our objective was always like, okay, you look at an image, say what is it, AI is done. So we started calling as nouns and verbs, where if you can recognize objects, we call it as a nouns are recognized. If you could recognize actions or videos or what you do, we say we are able to recognize verbs. We suddenly saw that, okay, look, we are pretty fine on that. Our accuracies are set to 2016. People went to one more level further. They started asking questions to an image. Tell me how many tomatoes are there in that basket. Or the people started answering questions and with certain accuracies. So it looks like things are moving fine. Of course, there is a significant progress, but I don't consider this as an end of this problem getting solved. A large number of problems are presenting. So this class of algorithms, when you try, you will also see equally bad or if not worse examples. Like you will get many of the industrial giants are possibly unable to use some of these on their products because you generate a caption which is hurting somebody's sentiment, you are in trouble. Your algorithm could make a mistake, and that mistake could be too costly. But in general, like we know the percentage accuracies or percentage compatibilities are moving forward, and we need to look at how this sort of algorithms can be used without getting into such troubles. And now, going beyond now, in the 2016 onwards, people talk about now, we are able to generate images, which means that we are understood it. So in a way, if I am able to generate, which means my understanding is correct. If I am able to answer a question correctly, my understanding is correct. So if I am able to generate, so this is the new thing, so these are all typically now popularly known as the deep learning and its various avatars that generate this sort of results. Okay, so what does it mean to us? So in a way that this means that what we have achieved at this moment is a certain level of accuracy in computer vision. So now our accuracies have crossed the threshold, but there's not guarantees have achieved. So you have your accuracy crossed the threshold where we can now start building applications. Users can be happy. You can build solutions smartly such that these things are going to work. So at the same time, on the research front, we are now moving more and more into very fine recognition problem, very structured recognition problem, very interesting. A new class of problems are now coming, like the captions came, now the question answers came. You have the problems which are popular in typically the IR or NLP or many other areas are now seamlessly getting connected to computer vision. So the vision, text, speech, all of them possibly speak the same language. I'll also show you later on that, okay, look, not only same language, they have become interoperable at this moment now. So now this is asking us that, okay, can you think of now different ways in which what we have been doing can be done? Say, for example, if I search for a flight from Hyderabad to Bangalore, I think for the next 1 week, continuously Yatra or Make My Trip or somebody or other is going to push advertisement on low cost, this flight from this time to this place to my browser. Now, if I look at a person, oh, this dress looks very good. I don't have to type. So just my action, just I staring at you, just by looking at your laptop or a gadget, clearly tells that I'm interested in it. Just you go to a shop, watch on a device for a while, and come back. It clearly tells you are interested in buying it. Maybe I could advertise to you. Maybe I could send you an SMS that I'll give you at half rate. I could do bargain. So in a way, this seamlessly connect to a set of applications that run on the traditional marketing or the traditional databases. And this camera just captures your intent, captures your objective, maybe your preferences. And of course, the rest of the things like once I know your age and your preferences, there are a lot of things that I could transfer from your fellows and your friends and other things. Like, so that we have the rest of the pipeline, possibly we are completely enjoying it now. So this is a missing link. Looks like we are not too far from it. So our market basket analysis can be thought in a now a different way, because it could be physical objects in those baskets now. Okay, so that's a main point. It looks at this moment from my side where we are ready now. Computer vision is getting into use. Now let me take a couple of examples where this sort of vision ideas now where it is emerging and how it could go, and I'll connect to some of the work that we have tried to make some tiny steps in these directions. So if you talk about vision meets sports, like we all know that, okay, look, sports is a very, very powerful domain with a lot of interest, and vision has a lot of utility in it. But before we get into the sports, let me ask you a very simple question that, okay, look, how do you solve this problem? Actually, possibly we have a lot more value for it at this moment if you can solve this problem. I don't think we have any solution in any near future at this moment. But if I want to learn machine learning from Hinton, the father of deep learning or neural network learning, we know we have a solution. Okay, so in the education space, in the last few years, we have seen that this has like a shaken many of us in our education, the way we think of teaching, the way we thought that, okay, look, what we are going to teach and what the students are going to learn is like had a serious look at it in recent years because of online forums like this. And if you look at the technology, what they use, I'm sure most of you know the type of technology it's it just came at the right time and it worked. What about if you want to learn badminton from Gopichand? So if your if your requirement is something different, if you want to scale the rare resources that we have in the country and reach out to somebody who is in Manipur and want to have access to something that is available in Bangalore. So we possibly need different type of technology in the present day where how do we, it's not just the multiplexing or just the streaming of the videos. One should go well beyond that. And the classical example of AI, if you look at it, that always had sports or games in mind. That was the chess. Chess was a synonym of AI. Now, AI is, but if you put a camera to it now, you can actually play chess. You can do a physical chess, not really the board, the computer game. You can make move and the robot can see it and robot can do the counter move. Why don't we do the same? There's a lot of opportunity in this space if you can have eye to the machine. So we are not closing the loop. So what we do is in the bowling mission is we throw the ball. We need to close the loop. So cameras can go actually well beyond the broadcasting, which is our primary use as of now. And this space is now looks we are ready to do. If you can do that, we can do a lot of analytics. What we could do, we could look at this sort of like finding the heat maps, finding the people movement, finding the foot movement in the sports is getting more and more popular, and very often that is done by manual counting or doing designing strategies for a competition. So a couple of years back, I was in a computer vision conference where we got the coach from the Australian Cricket Board. He was talking about the technology that they use for managing the failure of the pace bowlers. What they need is basically like a band which logs the pace bowler's activity. What you need is basically like to know the workout, like what you have presently is that the data from only the matches, which are documented, how many balls you bowled and how many run-ups and what space you ran. How do you capture this? So I'll show you, say, a piece of work that we did. So this sort of mechanisms can give you the low-level analytics. Now, if you want to go to the next level, so what we have is two very different modality. One is a video that we all enjoy. One is a human understanding output. It's not a machine generated, it's a human understanding of what is happening in this, which come from a very different source. How do we use this for improving it? Assume if you can just map both of them into a new domain, a new virtual representation. You have two sequences or two continuous or two time series. You have two sequences, one in the text, one in video. And if I can just align them with a simple dynamic programming, the textbook algorithm, then what we have achieved is every shot or every clip of it is annotated with text. And we know once it is text, a class of analytic algorithms, a class of strategy algorithms, a class of retrieval algorithms can be enabled down on top of it. Of course, there is no great learning. So this we did maybe many years back when when this learning was still not this popular. But this is not possible always. This is a way to cheat the human understand the machine learning or the learning by using Cricinfo. What about if your problem is something like this? So if you are given a set of videos and associated commentaries, and our job is to write these commentaries. Of course, not one is to enjoy the commentary. Second is that okay, now you could process text and provide a lot of useful information for human consumptions and planning and execution and training in this way. So this is possible. So the way the caption in the present deep learning setting people do, if you use it, you get something like a caption which is meaningful but not possibly useful. So what we need is basically a description which is more like a commentary. And the way we attempted was by looking at two players. We picked, of course, tennis, which is a easier game for visually. There are less people moving, less noise. And we could analyze the two players and know what they do and understand what each of these players are doing and generate commentary which is more like human understandable commentary. These are a few qualitative examples of the type of things that machine could generate. Okay, I'll show you one more application of it, of computer vision, where the computer vision meets the heritage or the tourism around. So where this is a class of applications that enable us to access the monuments around from Hampi, where you go and take a picture tells you what you're seeing. So we all use the audio guide or things where you go, have a device where you go and press 1, press 2 and listen to audio. One way is to replace it with GPS. That's what you get sometime in museums. You go there, with GPS will tell you you're close to this painting, it will tell you a story. But it doesn't really tell you that, okay, you're looking, on your left there is something. It doesn't know whether it's on your left or right. When you look at it, it doesn't say you what, it doesn't know what you're looking at it. If you can embed into a wearable device, what you're enabling is a set of possibilities. So here our interest was in doing this computation on a medium-end or a low-end phone or a device at that stage, where a complex object recognition algorithm, which was till then considered to be mostly a server class business, now is ported to a mobile phone for a specific location. And similarly, if you want to augment or if you want to visualize something that does not exist at this moment, like a painting, I could see the original when you are looking at it. So you have a lens through which when you see, you don't see this, you're augmenting, you're visualizing, the closest now is again becoming the popular term called the virtual reality or augmented reality type of settings. So in a way, traditionally we know the compromise between storage and computing. You can do a lot more computing and reduce storage, or you can do a lot more storage and reduce the computing type of trade-offs we had seen. The AI throws one more dimension, that's accuracy. You also say that, okay, look, how much accuracy you need. You need more and more accurate, maybe you need more and more compute, or more and more storage. So you can decide an appropriate operating point depending on the use case. So another application in the domain of heritage. So if you look at, you go to a tourist place and you walk around, what happens is usually you see is somebody explaining a story. So somebody will show you, a tourist guide will show you, this is what is this monument, this is what is this monument, etc. But assume we can do a similar thing automatically. Because what it requires now is understanding where you are, GPS++, knowing where you are looking at it, Google Glass++, understanding the image or recognizing the objects, recognizing the buildings, generating language. So a set of things that possibly exist, and then synthesizing the audio. So you have a series of steps where each piece is possibly now almost ready for use. So the text part, the audio part, the speech, the NLP, the vision, they are all being revolutionized with the huge data. So in the opening talk, Chris mentioned about this, what has really happened is surely in this space is a huge data that people have collected and the huge computing that became available. These two had suddenly revolutionized this in this space. And that has enabled a class of applications over images, video, speech, and text. Okay, let me summarize. So what computer vision is now guaranteeing is that it is going to work soon. Or it has started working. You can have applications that run on servers to your mobile phones and maybe seamlessly connect to your rest of the engineering pipeline. And of course, as a research, we are now looking deeper and deeper into what we mean by understanding, what we mean by problem solving, what we mean by strategizing based on the visual data. Okay, that's all. Thank you.
Spawned off a new kind of a human process outsourcing, which is on annotations. I see a lot of
Mechanical Turk sort of thing?
kind of thing.
Yeah.
So you think the futuristic solution you're talking about, automated annotation, which will,
actually a number of Mechanical Turk annotation is possibly for machine learning.
correct, but
Yeah.
with your automated,
So usually most of these automations will be used for as an initialization.
initialize.
Yeah.
So it won't eliminate
It won't eliminate.
mechanical.
Yeah, it is actually, by annotating, you are eliminating the job for tomorrow. Because you're providing images or videos which is going to be used for learning, which is going to close this.
Mostly, a lot of success came out with the Alex Krzyzewski paper, as you said, with the deep convolutional neural networks. It's still a supervised learning algorithm and still requires massive amounts of data. Is there research going on in coming up with some online learning algorithm can do some data processing on the fly to update its parameters and preserve the intelligence?
So there is a lot of interest now on more like a weakly supervised learning and unsupervised learning. So where you don't need this much of supervision. There's interest, and people are moving more and more towards that. Because we cannot keep on annotating every damn object in the world and build models based on that. Thank you.